Hi, Mr. X with Glossary Term Binomial Theorem. Let's just start with a little picture of Pascal's triangle. Here are the top 6 rows of Pascal's triangle. Technically there are 7 rows, but we call the top one by itself the 0th row. So we have first row, second row, third row, fourth row. Keeps it straight. These numbers right here indicate the number of the row. So our bottom row in this particular graphic is the 6th row. Now look what happens when we expand a simple binomial. This is really pretty cool. The numbers from Pascal's triangle give us the coefficients in our expansion. You see the coefficients of 1, 4, 6, 4, 1? There they are. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So look for the patterns here. And the real value of being able to expand a binomial is not that somebody's going to ask you when you go out to the workplace, hey, Fred, can you expand a binomial for me? Chances are nobody's ever going to ask you to do that. The value of studying this business is to get a handle on manipulating technical material, being able to see patterns, being able to use the language of math and the powers of reason to solve problems. It's being able to handle technical material why we study the binomial theorem. Anyway, let's expand this out. If this had one more line here, if we had one more line that said x plus y to the 6th, what would we get? Well, let's expand that out. We're going to take x plus y to the 6th power as if it was written right here. Because just as Pascal's triangle goes on forever, this list of expanded binomials goes on forever. X plus y to the 6th equals, well, the first term is x to the 6th. The next term would have a 6th coefficient from Pascal's triangle right here. And we'd have x to 1 less power and y to 1 more power. There's a y to the 0 sitting right here. Let's keep going. Plus 15 is the next number. X to the 4th y squared. See the pattern? Plus a 20. X cubed, y cubed. Next term, 15. This 15 is this 15. Of course, you might also notice that the whole thing is symmetric, left and right. X is now raised to the 1 less power. Y is now raised to the 1 more power. And you might notice that because we're raising this to the 6th power, our exponents always add to 6. 5 and 1 is 6, 4 and 2 is 6, 3 and 3 is 6, 2 and 4 is 6. Could you get the last 2 terms by yourself? Do you see the pattern? And one more term. Binomial expansion from the binomial theorem. Learn the language of mathematics at MrXMath.com.